projects. In this video, we are going to explain about the project titled Topic Modeling and Progression of American Digital News Media during the onset of the COVID-19 pandemic. The project aims to thoroughly examine how American digital news sources have changed in light of the COVID-19 outbreak. It is very important because it sheds light on how news coverage and attitude changed over this crucial movement, helping us to better understand society reactions and worries. The project uses a number of cutting-edge methods such as LDA, topic extraction, BART, CNN plus BERT, machine learning models, and sentiment and news classification data to extract insightful information. By doing this, it gives scholars, media experts, and policymakers a useful tool to help them navigate the rapidly evolving world of digital news media at times of international crisis. The project's goal is to thoroughly examine how American digital news media changed in reaction to the COVID-19 pandemic. It tries to identify moving patterns and feelings in news content by utilizing a variety of algorithms and approaches such as sentiment analysis, machine learning models like BART, logistic regression, and extra tree classifier, and LDA, topic extraction. These algorithms are essential for deriving insightful knowledge from huge datasets, enabling a great comprehension of American digital news media changed and evolved over this pivotal period, and eventually assisting in media analysis and informed decision making. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirement. In software requirement, we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, essential Python libraries like NumPy, Pandas, Seaborn, Matplotlib, sklearn, etc. and frameworks are imported to provide the necessary tools and functions for data analysis, machine learning, and web development. Second module is exploring the data set. Sentiment data and news classification data. Sentiment data. This phase involves in-depth exploration of the sentiment dataset, which likely contains information about the emotional tone, positive, negative, neutral, of news articles or comments. Understanding the dataset structure, content, and potential issues is crucial. News classification data. Similar exploration is conducted for the news classification dataset, which may categorize news articles by topics, enabling better comprehension and modeling. Third module is data processing. This step focuses on cleaning and pre-processing the data, removing punctuations and mentions. Special characters and usernames, that is @username, are removed to ensure text consistency. Removing characters. Unwanted characters or symbols are eliminated to enhance data quality. Removing spaces. Extra spaces are trimmed to standardize text. Lemmatization. Words are reduced to their base or root forms to simplify text analysis and improve accuracy. Fourth module is visualization using Seaborn and Matplotlib. Data visualization libraries like Seaborn and Matplotlib are employed to create informative charts, graphs, and plots. These visuals offer insights into data distribution and patterns, enhancing data exploration. Fifth module is feature selection using Pandas iLog. Feature selection is vital for model efficiency. Pandas iLog is used to choose specific attributes from the dataset that are relevant to the analysis, thus improving model accuracy. Sixth module is tokenization. Tokenization is the process of breaking text into individual tokens, words, or phrases for further analysis. Different tokenization methods are used. First one is lexicon vectorizer. Likely a method to convert text into numerical representation suitable for machine learning models. BERT tokenization utilizes BERT, B-E-R-T, a state-of-the-art NLP model to tokenize text, beneficial for advanced NLP tasks. Keras tokenization applies Keras-based tokenization, which may be useful for deep learning models. Seventh module is splitting the data to train and test. This step involves dividing the dataset into two parts: a training set used for training machine learning models and a testing set for evaluating the performance. And the 8th module is building the model, in which we have different algorithms. Multiple machine learning models and algorithms are used in this module, including BART, B-A-R-T, which is a combination of CNN plus BERT. This model combines BART, bidirectional and auto-regressive transformers, CNN, convolutional neural network, and BERT, bidirectional encoder representations from transformers architectures. BERT is used for contextual word embeddings, while CNN captures local features, and BART for text generation. It's likely employed for advanced text analysis, including summarization, sentiment analysis, and news classification, leveraging BERT's contextual understanding and BART's text generation capabilities. Second algorithm is logistic regression, a simple linear model used for binary classification tasks. It models the probability of an instance belonging to a particular class. Logistic regression may be utilized for sentiment analysis and binary news classification tasks due to its simplicity and interpretability. Random forest, an ensemble model that combines multiple decision trees for robust classification. It reduces overfitting and provides feature important scores. Random forest is valuable for news classification and sentiment analysis tasks due to its ability to handle complex data patterns and interpret feature importance. Extra tree classifier. Similar to random forest, extra tree classifier is an ensemble model with a focus on reducing variance by using randomization and feature selection. It may be chosen for its robustness and potential improvement in classification tasks, especially when dealing with noisy data. KNN, K nearest neighbor, a simple yet effective classification algorithm that assigns data points to the class most common among their K nearest neighbors in the feature space. KNN may be employed for text classification, especially when considering the context and similarity between news articles or comments. Decision tree, a tree-based model that makes decisions by recursively splitting data based on feature values. It is interpretable and easy to visualize. Decision trees are useful for binary classification and decision making in news, categorization, or sentiment analysis. Naive Bayes, a probabilistic model that uses Bayes' theorem with the naive assumption of independence between features. It is suitable for text classification. Naive Bayes is commonly used for sentiment analysis and text classification tasks due to its speed and effectiveness. SVM, support vector machine, a powerful classifier that finds a hyperplane to separate data points into classes while maximizing the margin between them. It can handle high-dimensional data well. SVM is versatile and can be applied to various NLP tasks, including news categorization and sentiment analysis. MLP, multi-layer perceptron, a deep learning model composed of multiple layers of interconnected nodes, neurons. It's effective for capturing complex patterns in data. MLP is employed when complex, non-linear relationships in the data need to be modeled, making it suitable for advanced NLP tasks. Voting classifier, LR plus RF plus SVC, an ensemble model that combines the predictions of logistic regression, random forest, and support vector classifier. It leverages diverse models to make collective decisions. Voting classifier enhances prediction accuracy by aggregating the results of different models. It's used when combining the strengths of multiple algorithms is beneficial. RNN, recurrent neural network, a deep learning model designed to capture sequential dependencies in data. It uses recurrent connections to process sequences. RNN are suited for tasks like text generation, sentiment analysis, and news article summarization, where sequential information is crucial. CNN, convolutional neural network, a deep learning model typically used for image processing but can also be applied to text data by treating text as an image. It captures spatial patterns in data. CNN may be utilized for text classification tasks, especially when patterns in the arrangement of words are important. Ninth module is training and building the model. This module focuses on the training of machine learning models on the pre-processed training data to make them capable of making predictions or classifications. 10th module is Flask framework with SQLite for sign up and sign in. Flask, a web framework, is employed for developing a web application that may include features like user registration and authentication. SQLite is used as a lightweight database to securely manage user data. And the 12th module is the given input is pre-processed. Count vectorizer. The user provided input undergoes pre-processing, potentially using techniques like count vectorizer to make it suitable for analysis. And the 13th module is trained model is used for prediction. Machine learning models, possibly the previously mentioned extra-tree classifier or others, are applied to predict or classify user inputs based on learned patterns. And the 14th module is topic modeling using LDA. Latent direct link allocation is a statistical model used for extracting meaningful topics or themes from the processed data. It offers valuable insights into the content and themes of the input data. And the final module is final outcome is displayed through front end. The project's results, including predictions, topics, or insights, are presented to users through a user-friendly front-end interface, making the findings accessible and understandable. This is the accuracy comparison graph. On the x-axis, we have the different types of algorithm, and on the y-axis, we have the accuracy count. And from this graph, we can say that BART performs well. Execution. For the execution of the project, we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, home.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are the model files. These are the model files which contain algorithm information which will be loaded into the project code during runtime. And this is the notebook file. This is a Jupyter notebook file which contains a combination of code, graphs and output all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So first we need to copy the code folder from the address bar of the file explorer. So I'm copying the code folder path and open Anaconda prompt. Use the cd command followed by a space and then paste the copied path. And now hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python app.py. So I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and port. Now we need to copy the local link. So I'm copying the link and paste this link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So here we have the sign up button. Click on sign up. So if we are new, we have to register first, but I have already registered, so click on sign in. So this is the login account where we need to enter the username and the password. So I'm entering the username and the password. And now click on register. So this is the home page of the project. So here we need to enter a message, and this message will predict the sentiment. So here I have entered this message. Now click on predict. So this is the result which we got. This is the message which we have entered, and the text type is to, the tweet type is positive. So the sentiment of the message is positive, and the topic for the paragraph is most dependent upon these words: can't, claim, falsely, told, recall, etc. So in this way we can predict the sentiment of the message. Now let us enter one more message. Click on sign up. We have already registered, so click on sign in. Enter the username and the password and click on register. Now we will enter one more message and then predict the sentiment of the message. So here I have entered one more message. Now let us click on predict. So the results for comment are, this is the message which we have given, and the label here is, the text type is 1, the tweet type is neutral. So here the tweet type is neutral, and the topic for the paragraph is most dependent upon these words: Afghanistan, Taliban, report, say, etc. Now let us enter one more message and check the sentiment. Click on sign up. Click on sign in. Enter the username and the password and register. Now let us enter one more message. This is the message which I have entered. Now click on predict. So here we can see this is the message which we have entered, and the label for this message is, the text type is 0, the tweet type is negative, and these are the topic for the paragraph is most dependent upon these words: AMP, embarrassment, service, etc. So in this way, by entering the message, we can predict the sentiment of the message, that is whether it is neutral, negative or positive. Now we will click on sign up again and click on sign in. Enter the username and the password and click on register. We will enter one more message and check whether it is positive, negative or neutral. So this is the message which I have entered. Now click on predict. So here we can see this is the message which we have given, and the label for this message is, the text type is 1, the tweet type is neutral, and the topic for the paragraph is most dependent upon these words. And the conclusion of the project is, this project used a broad range of data analysis, machine learning and natural language processing methods to explore how the American digital news ecosystem was changing in the face of the pandemic. It successfully captured sentiment and accurately categorized news articles by using a combination of algorithms including BART, logistic regression and extra-tree classifier. The project's capabilities were increased with the addition of the voting classifier and extra-tree classifier. LDA, topic extraction, also uncovered important topics in media coverage. Overall, this project provides a profound grasp of how news media handled major crises, providing insightful information about how the media developed throughout such significant occurrences.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit Through Project's YouTube channel and subscribe.